The really hard thing about understanding the human impact on climate is the effect of aerosols. Their effect on the planet's radiation balance depends upon what altitude they're at, it depends upon what size the particles are, and it depends upon whether they absorb sunlight or just reflect it. But in addition, there's an even harder problem, and that's the fact that aerosols have an influence on clouds. We've had measurements of greenhouse gases, but we haven't had measurements accurate enough of the other major forcing, which is aerosols and their effect on clouds. What GLORY does is fill in that missing data. The big thing about GLORY is it will finally make aerosol measurements with an accuracy that allows you to determine their role in climate change.
GLORY is going to fly two instruments for us. The first one is called the Aerosol Polarimetery Sensor, or APS. It will be the most advanced sensor of its kind when we fly it. And the mission of the APS sensor is to help us characterize the particles that are in the atmosphere, both man-made particles from pollution and also naturally occurring particles from things like forest fires and volcanoes and those types of things.
This is a very complex instrument, one of a kind. It's the first instrument that will study aerosols, that was specifically designed to study the least understood cause of climate change, represented by aerosols.
We call it a polarimeter because it measures the polarization of light. Light is a wave, and the wave can either be going along in this way or it can be going along in this way. And which way it prefers to go is its polarization state. If you take sunlight, where sunlight doesn't have any preferred orientation, and you scatter it off little particles, when you look at the light that gets scattered by those particles, it will have a preferred state. And so you end up with a polarized signal. So that's the signal that we're looking at with the APS.
By measuring polarization of light, we can tell much more about the size of the aerosol particles, about their shapes, and even about their chemical composition.
One of the reasons that it's important to measure the aerosols from space is we get a global picture. But the other thing that GLORY does, which has never been done before, is measure all of the radiation parameters so you can characterize the aerosol properties much more accurately. And finally, it looks at a given place from several different angles. So that tells you the full information on the radiation field, and that allows you to infer aerosol properties much more accurately than any previous instrument has done.
It is this accuracy that will allow us to, for example, discriminate between natural and anthropogenic aerosols. And this is really important, especially for policymakers. We have no influence on the natural particles, but we have a lot of influence on the anthropogenic, man-made particles.
The data from GLORY is primarily for the purpose of telling us what the mechanisms are that force the climate models. How aerosols are changing and how clouds are changing because of aerosols. But also, the detailed information on the clouds is useful in itself for helping us improve our cloud models. And clouds are an important part of the climate system. We're finally going to make polarization measurements of the Earth from space. We've actually made more precise measurements of the aerosols on other planets than we have of the Earth. Given the fact that aerosols have a comparable importance to that of greenhouse gases, it's about time that we're finally doing it.